Okay, so what's polar form? Up to now, we've been writing complex numbers as a real part plus an imaginary part. And this is what we call rectangular form. Now, there is another way of writing complex numbers, okay? And it's something called polar form. Now, it is based off two things. The first is the angle made with the positive x-axis. Okay, so we call that the argument. Okay, it's just a new name. And or is still the modulus. So I've drawn a general complex number here, x plus yi. I've drawn it out, plotted there, drawn the modulus so you can see it. And then this length here is the imaginary part y, and this length here is the real part x. Now, if I wanted to rewrite this differently, I need something new for x and something new for y. So taking x, using the argument, the angle, to the positive x-axis, positive real axis, apologies, and the modulus. So I'm going to use cosine of the argument equals x over the modulus, multiply cross by or cosine theta equals x. Same logic for y. I'm going to use sine for y because it's the opposite. Sine of the argument equals y over or. So multiply cross by or equal or times sine theta equals y. So now x plus yi can be written as or cosine theta for x plus I or sine theta for y. We'll write the I first so it doesn't get confused with the argument. And then if I simply just factorize out the or, it's cosine theta plus I sine theta. And that is polar form. Okay, that is polar form. So, if I have something x plus yi, what do I need to write it in this form? Well, I need the angle to the positive x-axis. And that angle, if it's in the first two quadrants, is this way. And if it's in the bottom two quadrants, we call it the negative that way, okay? But we'll look at an example of that in a minute, okay? So I need the angle or the argument, and I need the modulus, okay? So let's look at an example. So with these, for the first while, just for all the homework tonight, just draw it out, okay? So minus root 3 plus I in polar form, okay? So again, draw a quick diagram. Minus root 3 plus I, put it there. Okay, the first thing I need to work out is or, and then this is the argument, just to the positive x-axis. So I'll find, I will find this reference angle first, and then I will do pi take away. Okay, and it's always in pi normally. Normally we do it in radians rather than degrees. Okay, so the first thing, or is the modulus here. It's using Pythagoras theorem. It's the square root of root 3 squared plus, and this is a distance of 1 squared. So that is root. Root 4, which is 2. Okay. Next, find the argument. Okay, so I'm going to find the reference angle alpha first. I'm going to use tan because I have, I'll call that root 3. It is minus root 3, but the distance is root 3. I'm going to use tan because I have opposite adjacent. So tan alpha is 1 over root 3. So alpha is tan inverse of 1 over root 3, which is pi over 6. Okay, so now the argument, if that was in the first quadrant, that'd be fine. But because it's in the second quadrant, and I want my arguments always to the positive x-axis, I'm going to say, what's that angle? Well, it's pi take away pi over 6, if you remember, or 5 pi over 6. That's theta equals. Okay, if you remember that from your unit circle. Now, so put it in the form. So, minus root 3 plus I then equals 2 for or. Maybe I'll write the general form, will I? Or cosine theta plus I sine theta. So or is 2 cosine 5 pi over 6 plus I sine 5 pi over 6. And you are done. Okay? That is it in polar form. Now let's say they ask you to put this polar form in rectangular form. Okay? How would you do that? In rectangular form. Well, I know I should get this back to this. So what I'm going to do is I'm going to get my calculator. And I'm going to work out cosine 5 pi over 6. Cosine 5 pi over 6. And I need to put my calculator in radians. Okay, so cosine 5 pi over 6 is minus root 3 over 2. So this is here is becoming 2 times minus root 3 over 2 plus I. Now sine, if I do the same thing, sine 5 pi over 6 is a half. So plus I times a half. Multiply the 2 in, I get minus root 3 plus 1i. Okay, so that is into polar form and back into rectangular form. Now I want to show you one more example of what happens if it's in one of the bottom two quadrants. So let's take minus root 2 minus root 2i. So if it's in either of these two quadrants, we're going to take the argument this way, and that means it'll be negative. It's going to end up being negative. Okay, so minus root 2 minus root 2i goes down like this. There it is. Okay, so we have a distance root 2 there. We have a distance root 2 there. That's or. And again, that's going to be theta. And this is going to be alpha. Okay, so it's always, if it's in the top two, it goes that way. If it's in the bottom two, it's this way. So it's a little bit different from a unit circle, that way. Okay, a little bit different from our trig. So, or is square root, okay, so it's Pythagoras theorem, this squared plus this squared, root 2 squared plus root 2 squared, which is, again, root 4, which is 2, not always 2, just so you know. And then tan alpha is root 2 over root 2, which is 1. So alpha is tan inverse of 1. And what gets me tan 1 pi over 4. Okay. Now, to get the argument, if I imagine going this way the whole way, that is minus pi. Now if I go back a bit, I'll get minus pi plus going back a bit pi over 4. So it's minus 3 pi over 4 is my argument. Okay, so minus root 2 minus root 2i is, or, which is 2, cosine of the argument, minus 3 pi over 4, plus I sine of the argument, minus 3 pi over 4. And that's it. Okay, again, you can go back by just subbing these into your calculator, finding out what they are, and then multiplying the 2 in. There's another example on page 304. Okay, so complete the questions which I'll have posted.